Okay. So, in Utah, the average age for people obtaining their driver's license is 17.4 years old, with a standard deviation of 1.2 years. So we are moving from confidence intervals on proportions to confidence intervals on mean. And it's the same basic idea, but when you have a mean, you also need the standard deviation. When you're dealing with a proportion, the standard deviation is based on the proportion. So if you have a data set where you know the mean, but you don't know the standard deviation, you can't build a confidence interval. You need to know how spread out your data is. So we plan on taking a sample of 250 drivers where we ask them how old they were when they received their license. So number one, is this histogram normal, right skewed, or left skewed? It's definitely going to be right skewed. Most people get their driver's license in their teens, and then those people that wait until longer, they're the ones that ruin the average. And they're on the right tail. So would we expect a single sample to be normal, right skewed, or left skewed? The sample should look like the population, only smaller, if we do a simple random sample. Okay, 3. If many samples were taken, I'll add that in there, should we expect a histogram containing those samples to be normal, right skewed, or left skewed? Normal, because it's a sampling distribution, right? Okay. Number 4, what is the expected average for our sample? 17.4. Okay. And what is the expected standard deviation for our sample? It should be about 1.2 years. Okay. 6, what is the average of the sampling distribution? 17.4. What is the standard deviation of the sampling distribution? So when we did proportion, remember we did the square root of pi times 1 minus pi over n, and that basically comes down to the square root of pi times 1 minus pi over the square root of n. And this is the standard deviation of the proportion. And then when we bring in the number of people in our sample, that's where the square root of n comes from. So the standard deviation for the sampling distribution for a population mean is going to be the population standard deviation, which is sigma, your favorite Greek letter, divided by the square root of n. So really, those are sort of equivalent. Okay? The square root of pi times 1 minus pi, it's sort of like the standard deviation of the population. And then to turn it into a standard deviation for the sampling distribution, we divide it by the square root of n. So when we switch over to mean, the standard deviation of the sampling distribution is simply the standard deviation of the population divided by the square root of the number of people we talk to. So in this case, we're going to take 1.2 and we're going to divide it by the square root of 250, whatever that is. So 1.2 divided by square root of 250. Okay. Now that's pretty small, right? So create an interval that is 2 standard deviations above and below the average for the sampling distribution. So 17.4 plus 2 times the square root of, let's just call it 0.076. Oh, why did I square root it? I don't know why. And then the same thing with the subtraction. So 17.248. Okay. What does this interval represent? You got the 95% right. It's not a confidence interval. It's not standard error. So if I wrote down those numbers, 17.248 up to 17.552. 95% of the sample means should land inside that window. So you go talk to 250 people and calculate the average of your sample. 95% of those samples should land inside that window. Okay? Now that's not to be confused with a confidence interval. A confidence interval is something we use to try to figure out what the population mean actually is. Okay. What? It doesn't really have a name. It's just a 2 standard deviation interval around the sampling, around the population mean. You're not going to see something like that on a test, but I wanted to distinguish probability of taking a sample versus confidence interval, which you get when you already have taken a sample. All right. Suppose you take a sample of 200 and, wait, did I skip something? No. Suppose you take a sample of 250 drivers and you get an average age of 17.49 and a standard deviation of 1.7. Is this sample abnormal? What would you say? No, it's not. Why not? It landed in our 2 SD range of the sampling distribution. Okay, the SD was higher than we expected, and the average age was a little bit higher than we expected, but the average age lands inside that window, so it seems pretty good to us. Okay, so now we need the standard error of the sample. And if you remember back to proportion, the calculation for standard error is exactly the same as the calculation for the standard deviation of the sampling distribution. We just change the variables. So now instead of sigma divided by the square root of n, it's s divided by the square root of n. And s is the sample mean, or the sample standard deviation right there. So it would be 1.7 divided by the square root of 250. Okay, does everybody get that? Now we can build our confidence interval. So our confidence interval, are we going to use the sample average or the population average? The sample average. In fact, we rarely have the sample or the population average. If we do, there's no point in taking a sample. So we need to take the sample average, 17.49, and we're going to add 2 times, I'm just going to call it 0.11, and then do the same thing with the subtraction. And I get a 95% confidence interval that is 17.27 minus 17.71. Okay, this isn't on your paper, but what is the probability that that is correct? This is a confidence interval because this one is based on a sample and the other was based on the population. Okay? So, what is the probability that this confidence interval is correct? 100%. The 0 doesn't come into play here because I know the population average. What is it? 17.4. Does 17.4 fit in that window? Yes. So I have a 100% chance that this confidence interval is correct. Does that make sense? Where are you stuck? So I told you this to begin with, right? In the future, we won't know that. So what we do is we take a sample, and our sample yields 17.49. And we assume that that's relatively accurate, right? And then we use the standard deviation of the sample to create a standard error. And then we do plus 2 standard errors and minus 2 standard errors. And we create this confidence interval. And normally we would say we are 95% confident that this interval contains the actual mean from the population. But we know the actual mean. The actual mean is 17.4. Does it fit in there? Yes, it does. Most of the time we won't be able to check it. We'll just be stuck with this interval, and it's either right or it's wrong, but we don't know. In this case, we did know. All right. So 13, did the confidence interval contain the average of the population? Yes, it did. Okay. All right. So what I want you guys to do is the same sort of questions on a different sample. All right. Okay. And now turn to the back. The Rossmann app collection does not have any way to create sample means and standard deviations. Like they don't have an app for that. So I just had to make up my own number. So suppose that the average height of girls at Emory High is 64.1 inches with a standard deviation of 2.9 inches. You are asked to take a simple random sample of 35 students. So 19, what is the expected mean for our sampling distribution? We would expect 64.1. Now I made that up, so who knows what it really is. Okay. What is the standard deviation of the sampling distribution? That's just going to be 2.9 divided by the square root of 35. And then you'll create an interval, all right? And then your job today is to talk to 35 EHS girls, and for once, you can ask the females and the males later in this class. Okay? Garrett, I'm not sure what you're going to do, because I'm not sure you have 70 kids at Green River High, do you?
It might be close.
Okay, do your best. Don't talk to the middle schoolers though. So if you end up with a number less than 35, it's fine. Oh, that includes middle school?
Yeah, so 7 through 12, we have just over 70 kids.
Okay, so just ask every kid 9th through 12th grade, and then you'll just have a different denominator than we do.
Okay.
All right. Well, Garrett, you can ask the teachers too. That'll work. All right. So you're going to find 35 data pieces, and you're going to write them all down. And then you need to find the average, which isn't too bad, but the standard deviation is a horrible mess. So I'm not going to make you do this by hand, but how do we calculate the standard deviation for a sample? Here's what you would do. Let's say that your average was 65. And you had 61, 66, 68, and so on. What would you do? Find the differences. So what's the first difference? -4 and 1 and 3. And then what do we, and then there are a bunch more. We square all of them, and then we add them all together, and then we divide by, you divide by how many there are, but that formula only counts when you talk to everybody. So if you talk to the population, you end up dividing by n. But since we did not talk to everybody, except in Garrett's case, Garrett, you can divide by n, I guess. So whenever we don't talk to anybody, talk to everybody, we're a little unsure that our standard deviation is going to be accurate. And so we have built in a little bit extra error. And that extra error is manifested by putting an n-1. And then you square root the whole thing. Okay? So what I want you to do is to find some app online. There are a million of them. But you have to make sure it's a sample average and standard deviation. If you just find a standard deviation and average calculator, it will divide by n, which isn't a huge deal for what we're doing. But see if you could find a sample average and standard deviation calculator. If you want to use Google Sheets, there's a formula that says S deviation P and S deviation S. Make sure you use the S deviation S button, and then it will divide by n minus 1. So that will give you, for number 22, that will give you your average and your standard deviation, and then you can finish those questions. The next table, oh, and you're going to compare that to my claim of 64.1, essentially. Okay? But in the last piece, this is a little more realistic. So suppose we have no idea what the true average is of all males at Emory High School. The best we can do, because we're lazy and cheap, is a sample. So you need to talk to 34 boys and then use some online data calculator to find the standard deviation and the sample mean. Oh, this question, sorry, get rid of 27. 27 doesn't make any sense because we don't have that, okay? So you will calculate your standard error and you will calculate a 95% confidence interval. Is your confidence interval going to be correct? We don't know. We'll never know unless you actually go and talk to every single person in the world. Well, at Emory High. Our population is students at Emory High. Oh, yeah, we're practically the whole world, for sure. Okay. All right. So you need to have your data gathered by, well, actually, why don't you just turn this in tomorrow? And if you're going to be gone tomorrow, we're going to go back and do that 4.2 and 4.3 practice. Okay. Get to work.